Hey everyone, it's Justin again. In the last video, we learned how to evaluate piecewise functions algebraically. But we know from experience that you can also evaluate functions by graphing them. So in this video, you're going to learn how to graph piecewise functions. We'll start with an easy one, just to get the process down. We need to graph each piece one at a time, starting with this piece. When evaluating, we always focused on the interval first, but when graphing, we start with the expression. We'll graph this just like it was a regular single piece function. It has a y-intercept of -5 and a slope of -2. Now that we have graphed the function, we can use the interval to restrict it. The interval is everything less than or equal to -2, so we only need this portion of the graph. Let's cut everything else out so that only the part on the interval is graphed. The last thing we need to worry about is how to end this segment. We've seen before that endpoints are always either open or closed points. Since the interval is less than or equal to -2, -2 will get a closed point to show that it's included in this interval. Now we can graph that second part, and the process is the same. Y-intercept, slope, interval, and the endpoint is hidden behind the other one because they overlap. Wait a second. This function looks familiar. This is an absolute value function. When you graph an absolute value function, you are actually graphing a special type of piecewise graph with two pieces. So now you understand why this unit started with absolute value. This time we're going to be using intervals that use interval notation, but the process is still the same. The first piece is a constant of 1 2/3, but only between the inputs of -infinity and -4, and we're going to stick a close point at that 4 because the bracket means it is included in the interval. For the next piece, we got a y-intercept of 1, slope of 2/3, and restrict it to the interval between -4 and 0. The point at -4 overlaps with a closed point, so we don't have to worry about that one, but we can put a closed circle at 0. For the third piece, the y-intercept is 4, and the slope is -3, but it's restricted to an interval between 0 and 2 with a parenthesis at 0 and a bracket at 2. The final piece is a constant value of -2, restricted to the interval above 2, which has a parenthesis, so let's give it an open point. Now that we've graphed all the pieces, we can see the full graph for this piecewise function, and we can use it if we need to evaluate specific inputs. Pause the video now and see how you do with this example on your own. Your answer should look like this. You have now finished this unit and learned about a few special piecewise graphs, as well as how to evaluate and graph any piecewise graph you come across. In the next unit, we're going to be diving deeper into an operation that we've only skimmed over up to now: exponents and roots. See you then.